Hi, so my name is Sara Hartse. I work here at Delphix.
I'm Brady, also work at Delphix.
And we're going to be talking about basically stuff we've learned in this last year about how devices are different on Linux and how to make it work with ZFS. Next slide. So yeah, we're going to talk about our motivation, a little technical background about why things are the way they are, some tools that we found really useful when trying to figure what we want our devices to look like, and then practical examples of our product runs on cloud platforms, as well as ESX, and talking about how we figured out device names on each of those platforms, and then some main takeaways that will hopefully help you make some fewer mistakes we did. So as an introduction, basically the problem we're trying to solve is there are a lot of different choices when it comes to identifying devices on Linux. And it's important to choose the right ones so that they interact properly with ZFS and with you as a user. So the first concept is the idea of a ZFS name. So ZFS needs to be able to uniquely and consistently identify devices so that it can reconstruct the same pool after exporting it. So just ZFS needs to know which device is which and how to find it if you've exported. This other concept, which is a little more nebulous, is the idea of a display name. And this is more the human-facing identity of the device. You want something so that you can match the devices that are in your machine and in your Z pool to their corresponding devices in your VM or cloud management software. So that, oh, I'm going to remove that device, not this one, allowing you to add, remove, and expand the devices that you need to. And so our product exposes this device management option to our users. So we want to make sure that A, the ZFS pools didn't break if you rebooted, and also users could confidently manage their own devices and know what was going on. So here are just a couple examples of the multitude of choices you have for device management and some examples of common actions you want to do. You have creating a pool. You're like, what are my device options? SDB looks great. And then you're like, oh crap, I should have used a different link. You can do zpool import -d to pick a different device link option for your pool. You can add devices. This is an example of using an Azure path. You can remove devices and then expanding devices with GCP. So those are all some examples of things you might want to do.
It's all talking this one? Okay. Yeah, so for those of you familiar with that have come from the Lumos background, you're probably wondering, what are they talking about? Because on the Lumos, you had this nice uniform C0, T0, D0, and it's very simple. And all the example, create pool tank always had those nice simple names. And so on a Lumos, that Z0, T0 name is actually a link, and it points to where the device is in the underlying bus and whatnot. And then there's this other concept called the device ID, which is that this uniquely identifies the disk. And on a Lumos, that's what's used to open up the pool devices. So even though you can move the disk around, it'll always open the right device. On Linux, though, it's why are there so many links? She referred to, you can see various different links there. And what's going on Linux is that the kernel actually scans the devices as they come into the system asynchronously. So SDA, SDB, SDC, those names will shift around. So they're not really good candidates to be opening your device if you store it in the cache file for the pool, because they're not going to be the right disk. So on Linux, to get that sort of consistent, you want the persistent or a consistent naming. The libudev or the udev thing that runs in the kernel, I'll go into that in a second, will give you a link that is persistent. So that's what you want for your opening your device. And on Linux, the concept of dev ID came in later, but we use the path, the actual path, which we don't use on Lumos. We use it on Linux to do the open. So you want that thing to be persistent. You don't want it to be SDA. Going into a little more details on Linux, there's sort of two components to this whole device naming scheme. There's Sisyphus, which is the virtual file system. People out there familiar with Sisyphus or ProcFS? Okay. On Linux, the kernel manages this thing called Sisyphus, and it has information about the devices that are published, if you will. And you can use that for finding out about the device, like its serial ID or things like that. And you can also use it to control state, like if you want to rescan the bus, things like that. UDEV, which is in user space, is a consumer of what the kernel produces. The kernel will send an event that says, I have this new disk SDA, and UDEV will come along and it'll say, oh, I want to create these persistent links. And it'll use different rules that you can write. There's some stock ones that come on each config. And there's even one for ZFS that you can take. I will recommend later that you take advantage of it. But it'll come along and make these names that are persistent or consistent. Like you always want it to look a certain way.
Yeah, so now I'm just going to go through a couple tools that we found helpful when trying to figure out like what are the options. Like Don said, ideally there are these links that are made available that are persistent. But one kind of complicating factor is we're talking about virtual machines with virtual devices. So what does it mean for a virtual device to have a serial number? Like, it's not a real device, it doesn't have a serial number. So what we found is basically different cloud vendors have kind of answered this question differently, and that has a lot of variation. But LSBlock is super helpful for just getting a picture of what's out there. LSCSI is similar except limited to SCSI devices. You can use the tree command. This is super helpful for figuring out just like what are the multitude of links that exist. So you can see some serial number like ID links, partition IDs once pools have been created, things like that.
Yeah, one thing to note is like you'll notice that these are all pointing back to that sort of transient name that's generated by the kernel.
Yeah.
So you want to be using these things because they're persistent, but those are not.
So Don talked a little about UDEV. There are some UDEV utilities you can use. UDEV ADM info will give you a bunch of the UDEV properties for a given device. This gives you insight again on which links are available, different paths available. And then UDEV ADM monitor tells you what UDEV events are happening in real time. So you can see devices come online, have links created. You can see like expand events, remove events, that kind of thing. And then of course ZDB. ZDB is really great for telling you what ZFS thinks is going on. So this is kind of the ground truth of like, I told zpool to create this pool based on this stuff. What does the actual VDEV think is happening? So here you can see we created this path, which is an Azure special path, and that's the ground truth of where it's going to go look for the device when it's recording. And then, yeah, the dev ID, as Don mentioned, isn't used in the same way as it is in Lumos. So that is confusing.
Yeah. Yeah, and then you might notice there's a physical path. So the distinction between the physical and the device ID is like who it is, and the physical path is like where it is. And that's used by Zed when it's trying to match up new devices coming in.
So yeah, now we'll go through the different examples of different platforms that we needed to make this work on.
Am I doing ESX?
Yeah.
Okay, yeah, so ESX, we found that when you reorder devices, the device names would change. So, yeah, and yeah, so on ESX, actually, when we first started out on Lumos, it just worked beautifully, and we were like, well, this is nice. But when we came over to Linux, we found that like there was no by IDs being generated. So we had to actually dig into the ESX and figure out there was a setting that was missing. And once you set that, it would generate UUIDs. So then you can have names, and you can't like in the same way. That the SDN names would move around, so that we didn't want to use those. So here's an example of the links that are generated on the ESX host.
Yeah, and then one kind of key thing about this is like, okay, great, we have this by ID link. but it's like completely ridiculous looking, right? Like if you're a user and you're trying to figure out, oh, which device was that? 3600C2. Yeah, like it's not a great display name is the takeaway from this. And so like the nice thing about Lumos is you had these names, where it is and what it is, and the what it is was always guaranteed to match up to the correct device, and we could display that. But it's a little more touch and go now with this device identification.
And then on AWS, there was actually nothing. I mean, this is the UW info, and on the other previous slide, you'd have all these links, and if you did the tree, you would see them all. On Zen, you just don't have that. You have this one single XE, very terse name, but we did find out by contract, as far as we can tell, it is persistent. So this is sort of the outlier, or doesn't follow. The typical rule is /dev something is not persistent. It is in this case, and so that's just another example of like, well, you have to understand what's going on. And they don't provide anything that's unique to glob onto for generating the by ID names.
Yeah, as I said earlier, like the idea of the device name or the ZFS name, because we're pretty sure this is going to be unique and going to be consistent, it works for the Z-pool name, and then it is also pretty useful for the display name if you're using the AWS CLI. This is how you refer to the device you're modifying, so that matches up nicely.
So yeah, and back to the dev ID thing, this makes it hard to sort of generate a dev ID because there's like nothing to glob onto.
Yeah, so then it came to Azure. We're looking at Azure, we're like, great, there's a dev disk by ID reference, let's use that. And then we did some testing and we found that it turns out if you resize your device in Azure, the dev ID changes, which is disturbing. And so, yeah, we read up about this. Azure actually provides, I still haven't figured out why it happens, but they do provide their own set of UDEV rules, which come installed by default with the Linux Azure agent. And so we decided to start using those. You can look at the rules themselves. Basically, they generate it based on the actual physical path, which hopefully, since there's not really a way to like move around devices in Azure the same way there is on ESX, because they don't really have a sense of like locality. This is consistent. And so yeah, you have this LUN name. It works well as the ZFS name, and then it's really nice as a display name as well because it matches what you see in the Azure CLI or NGUI. And then finally, GCP. So this was a platform we were able to add because we moved to Linux. And at this point, we started to see a pattern, which is like, if you have a by ID, use it, but then also test it a lot and make sure that it's not broken. And so, yeah, similar to Azure, GCP provided their own UDEV rules, which is nice because it kind of is like, oh yes, people like thought about how you should refer to devices, and it has this like word persistent in the name. So that seems promising. So we went with the by ID Google persistent disk name. And then again, similar to Azure, this works well as a ZFS name and as a like human readable display name. So that's where we are across all the different platforms right now. Some kind of main takeaways from this. Options for device naming are not consistent across different virtual platforms. As I said before, the question of like, what does it mean for a virtual device to exist? Like, what does it mean for a virtual device to be a device, to have a serial number, to exist in a like location? So it's important, especially if you're working across a bunch of different platforms, to take the time to understand which identifiers are available and which ones are most useful for your use cases. And I'd highly suggest testing different device operations, especially expanding devices, either warm expand or full expand, whatever platform support. And then finally, which is a kind of direction we're going to move, especially because we are trying to make this work across so many platforms, and we're trying to special casing each new platform that we support. But think about writing your own UDEV rules. Yeah, this, as I think John alluded to, this is an option for ZFS on like physical hardware. You get like an actual VDEV link based on a serial number. And it's a little weirder on the cloud platforms because you don't always have a serial number. But yeah, those are our main takeaways. Does anyone have any questions? Can you go to the next slide? Can you go to the next slide?
Oh.
Yeah, that's our influence lab. Yeah.
Have you seen situations where devices disappear for a short while? UDEV actually regenerates the old devices, and what we have seen in our case, we use iSCSI and log in to the iSCSI devices. For a short period, pretty much all the devices just disappear and then get deleted.
Interesting. Yeah.
You can't read from them. It just okay, no device found.
Yeah.
It's kind of weird.
Yeah. So the question is like, have we observed situations where the devices go away? So is it just like all the device links go away? Like you can't find it anywhere?
It's kind of weird. We
Yeah.
have still figured how it works. What we have now tried doing is doing UDEV ADM cycle so that we
Yes. Yeah.
just wait for all the events to set.
Yeah. That's what I was going to say is
Sometimes it just goes through.
this principle of like asynchronicity of like kind of devices are showing up when they are available on demand. And yeah, we definitely ran into weird behavior like that and UDEV ADM settle.
Yeah, so that sort of makes the ZPOol reports very unpredictable. You don't know if the device is there.
Yeah, we've also ran into this issue with Z-balls as well.
Yeah.
Like when the Z-ball links get finished creating, it's not always clear. Like ZPool create for a Z-ball will return before the link is actually finished being made. And so like maybe you expect it to be available, but it's not actually there in UDEV yet.
Do you have a way to fuse the devices exposed by multipath?
I don't think so. I don't think we have multipath
So
for
like
our
fiber channel
customers.
multipath or SAS multipath,
Yeah.
like look at the same device twice and we'll have the same serial number but two DAs, two SDBs.
We don't see that in the virtual space, but is Tony here? Yeah, you could talk to Tony because he's dealt with that on the physical side of things.
Yeah.
Richard.
Mr. Ward, a comment about UDEV ADM settle. It could take 3 minutes.
Yep.
It could take 5 minutes. It can take 2 minutes. Depends on your distro. And depending on the hardware, it can be always broken. So it's crazy. It sucks.
Yeah.
That's true.
In ZTS, we pushed in a patch last year or this year that tries to only trigger the device we're using, so we don't get hooked up on like a floppy drive that's acting weird.
Yes. We have also
So just beware, it's really leaky.
Oh yeah, Tom.
I was gonna mention that, but also sometimes when it says it's done, when you call UDEV ADM settle, it's not done.
Okay.
So
Great.
that was something that I was looking into specifically actually for the ZTS suite, where basically we have anytime we create a ball, there's like a 1% chance that any test would return like, hey, that device doesn't exist yet.
Yeah.
Because just hadn't finished what it's doing yet. And we tried adding UDEV ADM settle basically like the underlying command for that into the CFS source code for Linux to try to make that problem just go away without having to do anything weird. And it didn't work.
Yeah, I can help you out to hold this. Then let's get a little bit with that. Yeah, there is a lot of quirks.
Yeah, and so one of the things I was looking into was like doing an iNotify thing where it looks for the actual link to be created, but then it's like, well, what if how do you know if it's slow or if it's not going to get created?
Yeah,
That kind of thing.
exactly.
So there's just like all kinds of weird stuff there.
Last question.
Alan.
Would it make sense to be able to update the path message? So if you created the pool with SDB, SDC, or whatever, being able to use simply like VDEV properties to set the path to the by ID.
So that's already an
Have that update
option by using zpool import -d.
You will import it that way?
I want you to look pool is already important. And maybe just have it update the cache file and it's
There's update the losses.
And then the other question was, would it make sense to have an actual property called display name, where you could just set it to, if
Kinda like
it's set,
FRU,
you
yeah.
could call it just whatever you want and be able to know what it is.
That'd be nice, just to display the.
And then, yeah, basically, if that property set, we use that as equal status instead of the PDF name.
Yeah, we'll be around, so if you have additional questions, we're gonna move on to the next.